This video provides a summary of the procedure used to determine the elastic modulus of the hardened Portland cement concrete specimens, ASTM C469. When performing elastic modulus testing, the following safety precautions are required: safety glasses, closed-toed shoes, and a hard hat. Additionally, it should be mentioned that at no time should the safety cage around the apparatus be opened while the machine is running. The following equipment, materials, and supplies are required for elastic modulus testing: a 6-inch by 12-inch hardened Portland cement concrete cylinder, 6-inch diameter end caps, a testing machine capable of applying a controlled rate of loading, a system capable of measuring and displaying the load applied to the specimen in real time, a dial gauge apparatus capable of determining the relative displacement of 2 points on the specimen. First, place the dial gauge apparatus over the specimen. Align the apparatus and tighten the attachment screws. Once the device is securely in place, remove the alignment bars from the device. This allows the top and bottom parts of the dial gauge apparatus to move relative to one another. Next, with the machine off, place the 6-inch diameter bottom end cap into the device and carefully center it below the loading head. Place the 6-inch diameter concrete cylinder onto the end cap. Place the top end cap onto the concrete cylinder. Lastly, verify that the specimen is still aligned with the loading head, and then close the door to the safety cage, securing it with the pin. Using the concrete compressive strength determined from the 4-inch diameter specimens, estimate the failure load of the 6-inch diameter specimen. To do so, multiply the concrete compressive strength by the specimen cross-sectional area. The maximum load of the elastic modulus test is selected to be 40% of the load expected to cause failure in the specimen. Placing this maximum limit on the load will prevent failure of the specimen during the elastic modulus test, which could damage the dial gauge apparatus. Ideally, the loading rate used in the elastic modulus test would be equivalent to the compressive strength test. However, this would increase the difficulty of manual recordation of the dial gauge readings. Therefore, a lower rate, 100 pounds per second, is selected to allow sufficient time to record dial gauge readings for the purposes of this lab. To conduct the test, a minimum of 3 students will be needed. 1 student will read the load, 1 student will read the dial gauge, and 1 or more students will record the results. Once everyone is ready, the TA will start the test. At this point, the machine will begin applying load to the specimen at the specified rate, and the computer will report the load applied to the specimen. Upon loading, the dial gauge will indicate the relative displacement of the top and bottom of the device at the dial gauge. At specified load intervals, the student reading the load will call out the load, and the student reading the dial gauge will read out the measurement at that time. These measurements will be recorded by the other students. This procedure will continue up until the calculated maximum load is reached. At this point, the TA will stop the test. Keep in mind that since the test is non-destructive, it can be repeated multiple times if there are problems with data readings or recordation. Once testing is complete, turn off the machine. Remove the top end cap from the specimen and remove the specimen from the testing chamber. Next, reattach the alignment rods to the device and remove the dial gauge apparatus from the specimen. The 6-inch diameter cylinder should be saved for compression strength testing. For the lab report, it is important to understand how to interpret dial gauge readings. This slide provides a schematic of how the dial gauge works. Notice the rigid rod connecting the top and bottom parts of the device. The rod is located on the opposite side of the pivot point as the dial gauge. Accordingly, as the specimen deforms, the top half of the device moves closer to the bottom half by a distance denoted as delta. Since the rod is rigid, this motion also pushes the left side of the bottom of the device down by a distance of delta. Since the screws of the bottom of the device act as a pivot, this causes the right side of the device at the dial gauge to rock upwards a distance of delta. Effectively, the dial gauge reading is 2 times delta. Strain is calculated by dividing the displacement delta by the original length, L0. In the actual experiment performed in the lab, the dial gauge is the only measure of displacement available. Thus, to calculate the strains at different load levels, you must divide the dial gauge readings by 2 and divide by the initial length of the specimen. For example, if the dial gauge reading for a particular load level was 0.008, the actual displacement used for calculating elastic modulus will be 0.004.